For decades, Pluto was expected to be simple, a frozen, silent world at the edge of the solar system. But when NASA finally got a close look, it found something that shouldn't exist there at all. And that discovery changed how we think about distant worlds. Pluto sits billions of kilometers away from the Sun, in a region so cold that even gases can freeze solid. From Earth, it appeared small, faint, uneventful. Most scientists expected a surface locked in time, unchanged for billions of years. A place where nothing moves, nothing evolves, just a relic of the early solar system. But there was one problem with that assumption. We had never actually seen it up close. To solve that mystery, NASA launched a mission called New Horizons. Its goal was simple: reach Pluto, observe it, and finally answer a basic question: what is really out there? The spacecraft traveled for nearly a decade, moving faster than any mission before it. And as it approached its target, the first data started coming in. At first, everything looked exactly as expected, until it didn't. The earliest images revealed something unexpected. Brightness, not just a little, but regions reflecting far more sunlight than anticipated. That alone was strange, because over billions of years, space tends to darken surfaces. Radiation, dust, and impacts usually leave worlds dull and warm. But parts of Pluto looked fresh, almost as if something had recently reshaped them. That raised a new question. How can a world this cold still be changing? As more detailed images arrived, the picture became clearer. Pluto wasn't static. It was active. Vast plains appeared smooth, almost completely free of impact marks, which is unusual, because in space, surfaces accumulate craters over time. If a region has none, it means something is constantly renewing it. Something is erasing the past. And that something turned out to be ice. But not the kind you're used to. On Pluto, temperatures are so low that materials behave in unfamiliar ways. Substances like nitrogen can freeze solid. And under the right conditions, that frozen material can slowly flow, almost like a very thick liquid. Imagine a landscape where the ground itself moves, not quickly but steadily over time. This slow-motion reshaping creates patterns, textures, and smooth regions, a surface that is constantly renewing itself. But this leads to an even deeper mystery. Movement requires energy. So where is Pluto getting it from? At such a great distance from the Sun, external heat is extremely limited. So scientists began to consider another possibility. What if the heat is coming from inside? Data from New Horizons hinted that beneath Pluto's frozen exterior, there could be a warmer interior layer, possibly even a subsurface ocean. If true, this means Pluto isn't just a frozen object. It's a world with internal activity, a place where energy is still present, billions of years after formation. And that's not something anyone expected. But the surprises didn't stop there. Pluto also has an atmosphere, thin, delicate, and constantly changing. As the surface warms slightly, frozen material can turn directly into gas, a process known as sublimation. That gas rises and forms layers high above the surface. Then, as temperatures shift, it can fall back again. A continuous cycle, subtle but real. Even here, at the edge of the solar system, Pluto is interacting with its environment. Before this mission, Pluto was often described as a leftover, a small object in a distant region. But the data told a completely different story. Instead of being simple, it turned out to be complex. Instead of being inactive, it showed signs of ongoing change. And instead of being predictable, it became one of the most intriguing worlds we've ever studied. All from a single flyby. Here, where it gets even more interesting. Pluto isn't unique in its location. It's part of a vast region filled with similar objects. Which means, if Pluto can be this dynamic, how many others might be the same? How many distant worlds are still active, still evolving, far beyond where we expected anything to happen? Pluto didn't just surprise us. It forced us to rethink what's possible in the outer solar system. Because sometimes the most distant places aren't the most quiet. They're just the hardest to see. And now that we've seen one of them, the real question is, what else is out there, waiting to change our expectations?